these things are generally arrays, 1D or 2D. You can actually look at them in a table view as well with this other output here, which can be a bit more friendly for some of the outputs. So you can see what else is being produced by the protocol, but not necessarily plotted. You've also got some metadata sort of output. And the most useful one here is probably the standard out.txt. If an experiment run is not doing what you're expecting, and you want to go in and look in more detail as to why that's happening, you can actually look at the output that's produced by the simulation as it runs and its status output from the back-end simulator. Some bits of that are easier to understand than others, depending on how much you understand of what the simulator is doing behind the scenes. But that will give you a good idea, particularly for experiments that show red, because they haven't completed, where it was going wrong, and what sort of errors you're getting, whether from the simulation or from the post-processing. These just tell you what a summary of what was output and what plots were produced. You've also got all the plots available as EPS files, possibly more publication ready, and some debugging files if you're investigating further why you're not getting simulations behaving as you expect. You can look at, for instance, the CellML model that is actually being simulated. So after all the modifications have been made by the protocol, what the model actually looks like when simulations are being run, and the C++ code that's generated from that to run simulations. So you've got a bit more information in there to investigate further why you're getting particular behaviors. But if we look at an example of comparing versions of models, one example here is the DECA model, which the original CellML in the CellML model repository was not producing an S1, S2 restitution curve that you'd expect. When Joram visited the group a couple of years ago now, I think, I pointed this out and Gary had a look to figure out what was going on. So to show you the differences between the two versions, I'm looking at the protocol here and selecting compare models. And rather than comparing just two different models, I'm going to say show all versions and select the two different versions of the DECA model that are available for this particular experiment. And if I compare those, we can now see two quarterly S1, S2 curves. The top one in blue there is the buggy version of the model, and the orange one at the bottom is a much more sensible looking S1, S2 curve when the model has been fixed. And you can do similar things for the other protocols to see what other effects this bug in the model has. To see what the bug actually was, we can go and have a look at the model itself. So DECA 2009 here. And we can look at the C version table link here. And we've got the two different versions. I'm going to select both of those and compare. And there are two different ways in which we can compare those models. We can either do a straight Unix style diff of the raw files, but that's not particularly nice unless you like looking at XML. So there's a tool from Martin Sharm at Rostock that will compare models at a structural level. So we can use that tool running in Germany to look at how the mathematics has changed between the two versions of the model. And quite a lot of these things are just slight variations in the initial values for a different steady state of the model. But the main difference is in the sodium-calcium exchanger, which in the fixed version of the model has an extra term in there that was missed out in the original. And that was the main thing leading to the incorrect behavior. So that's a bit more about different kinds of comparisons. Now, adding your own models. And for this bit, I need to log in rather than just viewing public results as a guest. So let's log in with a demo account. There we go. And now from the menu up at the right, I've got a My Files section, which will allow me to create new models. Here's one I prepared earlier, which I'm going to get rid of so I can show you that it works from the start. So I can go to the CellML model repository, models.cellml.org, and have a look at the electrophysiology section and find a model of interest. And I'm going to pick the Lifshitz Rudy model from 2007, which is one that's not in the web lab at the moment. I can go and have a look at that and download the CellML file and download this file. So I'll store that on my machine. There we go. Right, so back to the web lab, and now I can create a new model. And I'm going to call this Lifshitz 2007 model for a demo. V1 for a version. I'm going to set the visibility here to private, so that's only viewable to me. You can also use restricted, which is then viewable to anyone with an account, or public, viewable to anyone even without logging in. So this is just a test case. I'm going to stick to private. And then I'll go and find that file that I downloaded on my machine. CellML file gets uploaded. I'm going to tick the box that says this is the main file for the model. Generally for a model, there only ever is one file. For protocols, that's more important. You select which is the main file of the protocol. And then I can go and create the model. So I've got my model. I can go and have a look at it. There it is. And I've also got a button here for running experiments. So I can pick some protocols to run on my model. So let's go and have a look at that. I'm not going to run everything because at least this account has a lot of processing results available to it. But the rest of you only have two processes available for running simulations. So you can only run two things at the same time. So let's pick a couple of things to run. Let's have the IKR IV curve and just a steady pacing to see what it's doing normally. We'll run those two. Okay, they're running. Started. You can see here links to the particular results, but often it's more useful just to go straight to the experiment screen and have a look. Here's my new model. Here are the two experiments that I've tried to run, which are showing up as inapplicable. The model doesn't have the relevant biology. Well, clearly the model does have the relevant biology, it's not been annotated with terms from our ontology, so the protocol doesn't know which variables represent the biology that's interested in. So there's a tool in the web lab that helps with annotating models, which is this little networky symbol to edit the annotations in the model. So we can click on that and we'll create a new version of the model with some useful annotations. And there are quite a few available. There's a little filter thing that says, just show me the annotations that are actually needed by the protocols that I'm interested in. So I wanted to run IKR, IV curve, and steady state pacing. Let's filter the annotations down to just the ones used by those protocols. And now I can go and drag and drop those onto variables in my model. So I'm going to drag time onto the variable called time. Voltage is going to be somewhere in here, I think. Yeah. Voltage is called V in this case. Stimulus current properties. Stimulus current itself, nice stim. The pulse amplitude is there. Pulse duration is there. And you can see these are getting grayed out as I use them, so you can see which terms you have already annotated and which you've still got to do. So we need some ionic concentrations, which I think come in the description for each individual channel, actually. Ion channels, rapid delay rectifier is in there. Stimulus current we've already done elsewhere. Physical properties we've already done. So it is just the ionic concentrations that I need to remember where they are in this model. The extracellular ones are up here. Extracellular potassium is there. And then the cytosolic concentrations. Don't think so. I think it's reversal potentials. Can anyone remember what component they are? Ask. Sodium. There we go. Intracellular sodium. potassium, cytosolic potassium. There you go, Ki. Now I've annotated everything in my list of required terms. So this time, just tick the give me an automatic version identifier. And I'm going to say rerun the experiments that were run with previous versions with this new version of the model. Save those annotations, wait a moment, and it says created 2 experiments as well. So we've got a new version of the model. And now if I go to the experiments list, I should see, yep, 2 experiments are running this time. That's good, they're applicable. And we should hopefully see in a minute some results. One other thing to note is that you don't necessarily have to go to the run experiment screen if you want to run something. Whenever you see a white box here, you can just click on it, which will start off that experiment running, and then wait for it to be complete. Might take a minute. Oh, there we go. IV curve is finished, and we can look at the results. 1 RKR IV curve for the Lifshitz model. Hopefully that looks roughly like what it should be. Okay, so that's it as far as the demo for adding new models is concerned. Go and have a play, add models that interest you, see what behaviors they can reproduce. Peter.